We are going to continue with exercise 13.2, question number 11. Find the derivative of the function sin x multiplied by cos x. In the previous class, I have solved the same question using the product rule. In this class, we are going to discuss how the same problem can be solved using the first principles. So let me write down the first principle. If I have any function f of x, then from first principles, the differentiation of the function f of x, which is given by f dash of x, is equal to limit of h tending to 0 f of x plus h minus f of x divided by h. This is the first principle formula. Let me take the given question as f of x. F of x is going to be equal to sin x multiplied by cos x. Now I need to substitute x plus h wherever x is going to be present in order to get f of x plus h. So I need to find out what is x plus h. I need to find out what is f of x. F of x is already given, so that I can write this as sin x multiplied by cos x. F of x plus h is not given. The same thing I can find out from here. Sin, instead of x, I'm going to have x plus h multiplied by cos x. Instead of x, I'm going to have x plus h. I have the value of f of x plus h. I have the value of f of x. Same thing can be substituted in the first principle formula. Upon doing that, I will be getting the value of f dash of x is going to be equal to limit of h tending to 0 f of x plus h, that can be taken as sin x plus h multiplied by cos x plus h minus f of x is sin x cos x, sin x multiplied by cos x whole divided by h. Right? Yes? Okay. Now I can take out h. Since h is common, I can write limit of h tending to 0 1 over h multiplied by, here I have sin x plus h and here I have cos x plus h. Right? Do you know the formula? 2 sin x cos x can be written as sin 2x, or 2 sin theta cos theta can be written as sin 2 theta. These are double angle relations, right? Okay, now I have sin x plus h multiplied by cos x plus h. I need to somehow write it as a double angle. By writing that, I can substitute over here instead of sin x plus h and cos x plus h. It is similar to taking 2 sin x cos x. So sin x and cos x can be written as sin 2x divided by, right? Similarly, if sin x cos x can be written as sin 2x divided by 2, here I have sin x plus h multiplied by cos x plus h, that can be written as sin, right? Or I can write over here 2 sin, right? 2 sin theta cos theta. This is 2 sin theta cos theta, right? 2 sin theta cos theta, the same thing can be written as sin 2x. So I can substitute the same over here. Upon substituting, I will be getting the value of sin 2x is there. Here, instead of x, I have x plus h. I need to write x plus h minus. What do we get over here? What will I be getting over here? It will be just sine x cos x. Yes. So I can write sine x cos x. Here I'm going to have divided by 2 as well. I'm going to have divided by 2 as well. Now, if I have to take this as common, right? Now, if I have to take this as common, what I can write this as? This can be written as limit of h tending to 0, 1 over 2h multiplied by sine x plus h minus sine 2x. Right? Now, sine x plus h minus sine 2x. This can be expanded. I will be writing limit of h tending to 0, 1 over 2h. This can be written as 2 cos a plus b, sorry, a minus b and sine a minus b. So how do I write that? So this is of the form sine a minus sine b. Sine A minus sine B can be written as 2 cos A minus B and multiplied by sine A plus sine A plus B. Substituting the same, I will be getting the value here 2 cos A minus B. A is going to be x plus h. It is going to be 2x over here. Minus of minus is going to be plus. So I can, what I can write over here? Of course, here I have one 2, right? Here I have one 2. Yes, I have to consider that 2 also. So 2x I can write 2x plus 2h, right? Minus of minus 2x over here multiplied by sine. It is going to be 2x plus 2h, right? Plus minus 2x. It is going to be divided by 2 over here. It is going to be divided by 2 over here. Further, I can simplify this as limit of h tending to 0, 1 over this 2 and this 2 can be cancelled. So I can write 1 over h multiplied by cos, here I have 4x plus 2x divided by 2 multiplied by sine. Here it is going to be 2x and 2x are going to be getting cancelled. It is 2h divided by. This is what I'm going to get. Further, simplifying, I will be getting limit of h tending to 0. 1 over h will be as it is. 2 can be cancelled over here. 4 divided by 2 is 2. 2 divided by 2 is 1. This can be written as cos 2x plus it is going to be, this is going to be x, no, 2x and this is going to be h, right? This is going to h, this is going to be h. So cos 2x plus h, or what did I have? 2x plus, no, sorry. Here I should be taking cos 2x plus h, right? 2 and 2 will be getting cancelled. H will remain as it is. So I can write 2x plus h multiplied by, here 2 and 2 are going to get cancelled. I can write this as sine of h itself. Now I can take the limits. Limit of h tending to 0, cos 2x plus h, and here I can take limit of sine h divided by h. Since the both are multiplied, I can take h over here because I have a formula which is limit of x tending to 0 sine x over x. What is this? Is it going to be 0 or 1? It is going to be equal to what? What about tan x divided by x? 0. Tan x divided by x is going to be equal to 0. Sin x divided by x is going to be equal to 1. Similar, same way I can solve for this as well. Limit of h tending to 0. When I substitute h is equal to 0, I will be getting cos 2x plus 0. And here limit of h divided by h, sin h divided by h, directly I can write the value as 1. Anything multiplied by 1 is the same value, so I will be getting the value as cos 2x. Cos 2x. When I solved using the formula as well, I have got the same value, which is cos 2x. So depending upon the question, whether they have asked from the first principles or whether they have asked directly, you need to take a call on how you are going to solve the question. In both the cases, the answer is going to remain the same. All right, clear? Okay, fine. Now let me solve one more question, from, or we can solve by any other method also. So this is one of the method just I have shown. All right, next I have secant x. Right, how can I solve the value of secant x? Right, now first let me consider the function given to me as f of x, or you can consider as y also, anything you can consider to be secant x. This is what I have considered. Now, do you know that secant x can be written as 1 divided by cos x? Yes? Okay, fine. Now, if secant x can be written as 1 over cos x, can I write f of x is going to be equal to y, which is going to be equal to 1 divided by cos x? Yes? Okay. Now, again, how do I solve this question? Can I use any rule over here? Any rule that I can use? Yes, no. Can I use product rule? Product rule says that if I have y is equal to u multiplied by v, two terms are multiplied with each other, then the differential y dash or dy by dx is given by which formula? It is given by u multiplied by v dash plus u dash multiplied by v. This is what your product rule says. Similarly, we have quotient rule also. What does a quotient rule says? If I have y is equal to u divided by v, then differential of dy by dx, differential of y with respect to x. I think somebody's mic is on. Please switch, turn off the mic. Okay. If I have y is equal to u divided by v, two terms are divided with each other, then the differential of y with respect to x is given by v multiplied by u dash minus u multiplied by v dash divided by v square. Which formula do you think I can use over here? Quotient rule, product rule, anything I can use over here? Yes, no? Can I use quotient rule? How? I'll be telling you. I have y is equal to 1 over cos x. Can I write this as 1 multiplied by 1 divided by cos x? Will the value change, or is it going to remain the same? It is going to remain the same. However, now I have y as two terms. The first can be taken as u, the second term can be taken as v, right? Now, taking u is equal to 1. The differential of u is going to be equal to 0 because 1 is a constant, right? Next, v is going to be equal to what? V can be taken as, v can be taken as v. Okay, you no, you can write this as or instead of doing this, you can use product rule. This way you can use the product rule, okay, by multiplying. If you want the quotient rule, then directly you can write this as 1 divided by cos x, where u and v are going to be 1 and cos x respectively. Yes, either you can use product rule also by writing 1 over x as 1 multiplied by 1 over x, or you can take v is equal to cos x and u is equal to 1 such that it is of the form u divided by v. Now, v dash is going to be equal to minus sin x because we already know the differential of cos x, right? I have the value of u, I have the value of u dash, v and v dash also. Substituting the same in the formula, I will be getting the answer. The formula is v multiplied by u dash. So I can write f dash of x, which is also going to be equal to dy by dx, can be written as v multiplied by u dash. V is going to be cos x multiplied by u dash is going to be 0 minus v dash is going to be minus sin x multiplied by 1 whole divided by cos x whole square. Going to the next slide, I will be getting the value of f dash of x, or the differential of y with respect to x dy by dx, which is cos x multiplied by 0 is going to be equal to 0, minus of minus, minus of minus sign is going to be plus sin x divided by cos square x. Yes. Now, further simplifying, I can write f dash of x, which is also dy by dx. This can be written as sin x divided by cos x multiplied by 1 divided by cos x. Cos square x can be written as cos x multiplied by 1 over cos x. Now dy by dx is going to be equal to sine divided by cos can be written as tan x, and 1 over cos x can be written as secant x. So finally you will be getting the answer. If y is equal to secant x, then the differential of y with respect to x is either tan x secant x, or you can write as secant x tan x as well. Both are one and the same. Is this question clear? Yes? Okay. Now, similarly, let me consider cosecant x. All right. Let me consider. Okay, secant x is done. Similarly, I will be considering this cosecant x. F of x can be taken as cosecant x, right? Now, if f of x is equal to cosecant x, what is going to be the differential of f of x? Now, starting, I can write f of x, which also can be taken as y, which can be written as cosecant x. Can I take it as 1 divided by sin x? Yes, this is of the form y is equal to u divided by v. I can solve it using the quotient rule, similar to the previous problem. Quotient rule says that the differential of y with respect to x, when we have two terms divided with each other, the first the numerator is taken as u, the denominator is taken as v, that is going to be v multiplied by u dash minus v dash multiplied by u divided by v square. Let me consider what is your u. U is going to be equal to 1. the differential of u, which is written as u dash, it is going to be equal to 0, since the differential of constants are 0. V can be taken as sin x. V dash, we already know the differential of sin x, it is going to be cos x. Substituting the same in the formula, I will be getting my answer dy by dx as v multiplied by u dash. V is going to be sin x multiplied by 0 minus v dash. V dash is going to be cos x multiplied by 1 divided by cos x, sorry, sin x. This is sin x, right? Yes. It is going to be sin x whole square. Simplifying the same, dy by dx is going to be anything multiplied with 0 is going to be 0. This can be written as minus cos x divided by sin square x can be written as sin x multiplied by 1 divided by sin x. Dy by dx is going to be equal to minus cos x divided by sin x is going to be cot x multiplied by 1 divided by sin x can be written as cosecant x. So you will be getting the answer of the differential of y with respect to x as minus cosecant x multiplied by cot x, or you can write minus cot x multiplied by cosecant x as well. Both are one and the same. So this is how you are going to solve if the question is given for cosecant x. Now, did you understand how to use quotient rule or product rule even though only one term is given? Yes? Okay, fine. Now, let us go to the next problem. 5 secant x plus 4 cos x. Consider y is equal to 5 secant x plus 4 cos x. The differential of y with respect to x is going to be the differential of 5 secant x and the differential of 4 cos x. Dy by dx can be written as phi is constant, phi can be taken outside. The differential of secant x, what is the differential of secant x? Differential of secant x is going to be, we just found out, right? Secant x tan x. Secant x multiplied by tan x plus 4 can be taken outside, multiplied by the differential of cos x is going to be minus sin x. Dy by dx can be written as 5 multiplied by secant x tan x, 5 secant x multiplied by tan x plus into minus is going to be minus. So I will be getting over here minus 4 sin x. Minus 4 sin x. This is going to be your final answer. Is that clear? Yes? Okay, fine. You can leave it over here. Let me go to the next question. Yes, cosecant x was there. We have already taken this, right? Okay, this is also similar kind of problem. Any further problems? No, they all are of similar kind. Okay, so you can try these out. I'm going to end with this problem, the seventh one. Y is taken as 2 tan x minus 7 secant x. Differential of y with respect to x is going to be the differential of 2 tan x minus the differential of 7 secant x. The constants can be taken outside. 2 multiplied by the differential of tan x is going to be secant square x minus 7 multiplied by the differential of secant x is secant x tan x. Upon multiplying, I will be getting the value of dy by dx as 2 secant square x minus 7 secant x tan x. Further, if you want, you can consider secant x as common. Secant x multiplied by 2 secant x minus 7 tan x. This is going to be your final answer.